So we have these sessions every week to do knowledge sharing on the different frame palettes within Substrate. Today we're going to go through vesting pallet's main purpose, why it's useful, go through some of its high-level features, its dependencies, relationships with other palettes in frame, other libraries, how it's used in the ecosystem, and then we'll do a deep dive. After we'll pause for some questions. If any of you want to stay afterwards, after questions, then we'll do some deep dive into the code, into the pallets code. Why is vesting useful? So we can talk about why vesting pallet is useful for the same reasons. We can talk about vesting being useful in a business scenario. And that's because vesting pallet works like a simplified version of real world vesting. And we'll dive into that in a moment. But in this way, it provides long-term benefits to the receiver of the vestments. And as a benefit, this helps ensure that the receiver remains in place, providing service long-term to the organization. So we can think of vesting as a win-win, and we can think of the vesting pallet as a win-win. So to introduce the concept of vesting that we'll be relying on for this presentation, let's think of vesting as an agreement that involves an overtime release of funds with a few different parameters that can be tweaked. So a common scenario for vesting is in a startup or like an early small business scenario. Founders or a founder wants to hire, onboard some early stage employees, and they're in a position like a lot of other startups where they may be lacking capital, and they want to incentivize people to stay and provide service. So they might define some shares. They have some shares of their company, and they want to give some amount of shares over some period of time to these early stage employees. And these employees are incentivized to do this because the shares gain value, because the company has its own value. So vesting pallet works a lot like this, except instead of getting some X shares over time, you're getting the tokens specified by the developer and over some period of time that's specified by the sender of those tokens. Okay, so with that, let's talk a bit about the vesting pallet and what it does. So the vesting pallet introduces vesting schedules. Vesting schedules are an on-chain agreement where some amount of tokens are released at some rate for some receiver at some point now or in the future, given by the starting block. So we can manage vesting schedules, and this is done through creation and merging of schedules. Creation might be self-explanatory, and merging is a bit more unique. I won't go into it, but I think we'll demo it in a few minutes so you can get a sense of what merging is like. And then finally, you can interact with the vestments or the vesting schedules, and that's through vesting. Vesting is just reaping those benefits, reaping those tokens, which you've earned over time from a vesting schedule that's assigned to you. So we can talk about its relationships with other components in Frame. There are no direct dependencies or dependents like within its actual cargo.toml, so we can move on to some of the other relationships. It implements vesting schedule, which is a common trait that's just used in Frame to define vesting schedules. And this is good because other pallets want to loosely couple with vesting. And this is kind of a nice design sort of approach for building pallets. So it's kind of a technical thing. To talk about its config, so the config trait is just a core part of Substrate pallets that allows a per deployment configuration of a pallet. It requires the lockable currency implementation, and it uses this to lock up the tokens as part of vesting. It needs to lock up somebody's balance and release it to them at some point in the future. So lockable currency is a great fit for that. Also, Balances Pallet implements this, so it's a natural fit for a lot of teams, especially if they just want to use the native token. And the pallet itself fulfills, I already mentioned that it implements vesting schedule. So the claims pallet also is configured to use vesting for the vesting schedule associated type on its config trait. And I'll explain what it does with that in a second. So to talk about how it's used in the ecosystem, we looked around and tried to find some places where vesting is used. So in Polkadot, it's used for payment. So members of Parity who are in countries that allow payment in crypto are able to receive payment through vesting pallet. I'm not one of those, so I can't really speak to this process, but maybe some of you all are familiar with it. It's also used for claims. So claims was a process involved with the launch of Polkadot, where people could participate in the launch of Polkadot and receive DOT, and they had to give their Ethereum addresses to claim those DOT. And some of these rewards were vested out. If you're not familiar with the claims process, I'm not too familiar either, but we can post some links in the chat, and so you guys can read up. And finally, it's used throughout the ecosystem for crowd loan rewards. So if you're familiar with the crowd loan process, teams seek support for their auctions. They're looking for users to lock up KSM or DOT, depending on the relay chain. And they often give out benefits in the form of some of their native token or assets to give back for the contributions that participants are giving. And if you think about vesting, this is a really natural fit for this process, because these teams may not want to give all of these tokens out all at once. They want to keep these new users engaged with their network, so they can vest out and give those rewards over time. And look at all the places it's used. So this is just some query that this is some query results that the data team provided us with. So thank you to the data team. These are all the teams that are using vesting right now. We can do a quick demo of the pallet.
So thanks, Justin. I'm gonna present my screen. Okay, so welcome everyone on vesting pallet demo. So this demo will be run as Substrate-based solo chain that I prepared with the usage of Substrate node template. In the bottom of that slide, you can find a link to my Notion page with the instruction of that demo and also with the GitHub repository. For that demo, I prepared 3 use cases. So the first one, imagine a situation when Alice has a super cool idea about blockchain startup. So she creates a company. Of course, she becomes a CEO, and also invites Bob to become a CTO of that company. Her idea is to provide some vesting in the very early stage to Bob, and it can be done in a Genesis block, which I'm gonna show you in that use case. And then with every minted block, Bob gets some vested tokens. So let's jump at first to Genesis configuration, and then let's check how it works. Okay, so for now you can see vesting pallet configuration for Genesis block. So to create a vesting schedule in Genesis block, you need to specify account to be vested. Also, you need to specify the starting block of the vesting schedule. So for the demo, it will be the first block. You also need to specify duration of that vesting. So for that demo, it will be 200 blocks. And also, you need to specify how many tokens should remain unvested. So we know the initial balance of the account. Also, we know the amount of tokens to be vested, in that case 200 tokens. So we need to calculate the difference between these two amounts. So that's how it's configured in Genesis config. So let's run the node and go to Polkadot UI. Okay, at first, let's have a look to accounts tab. So you can see that there are 200 tokens locked, and all of the tokens belongs to Bob. The same information can be queried in our chain state with pallet vesting, of course. Bob. Okay, so you can see 200 tokens locked for Bob. 1 token will be unlocked per block, and the starting block is the first one. So for now, I'm gonna show you how Bob can unlock his vested tokens. So Bob needs to send a transaction. He needs to call vest extrinsic just to unlock his vested tokens. Let's check the events. Okay, in the events, you can see that the vesting for Bob has been updated. And also in that event, we can see the amount of tokens that are still unvested. The same we can see when you go to account page, and we will see the same amount of tokens that are unvested and still locked. So that was the first simple use case for pallet vesting. Okay, the second use case, imagine a situation that Bob, our CTO, hires Substrate developer, Charlie, and with our CEO Alice idea, every developer should get some vesting. So when our chain is running, the only way to provide some vesting is to send a vested transfer to the recipient. And also in that use case, I'm gonna show you how Charlie can unlock his funds without having any tokens from the beginning of his account on our blockchain. Okay, so go back to our Polkadot UI. So at first, I need to send vested transfer to Charlie. Charlie will get 100 tokens. Also, Charlie will be having 10 tokens unlocked per block. And the starting block for that vesting will be 35. Okay, let's check events. So these two events corresponds to making transfer to account that has no money. Also, it says us that Charlie got 100 tokens, and also we got some information that our vesting has been created, and also has been updated because it already started, and you can see that some tokens has been already unlocked for Charlie. Also, I told you that in this case, I'm gonna show you how any account can unlock some tokens that are locked with vesting for our specified account. So basically, Bob will unlock some funds from vesting for Charlie with vest other extrinsic, and in that case, our vesting is completed. So okay, so in that case, we can see that our vesting schedule is completed for Charlie, and also there is no vesting schedules for Charlie in our chain state for the highest block. You can see none. That was the second use case. And the third one, okay, imagine a situation when our CTO hires another Substrate developer, Dave. Dave, of course, gets initial vesting, but Dave is so good that he gets promoted to being a lead developer in that company, and with that he gets another vesting. So in this situation, Dave will have two different vesting schedules, and in this use case, I'm gonna show you how Dave can merge these schedules into a single one. So go back to Polkadot JS. Okay, let's send the first transfer to Dave. Also 100 tokens. 1 token unlocked per block. And we will start with block 70. Okay, we can see transfer event and also information that vesting for Dave has been created, and there are 100 tokens still unvested. So let's unlock some tokens from that vesting to Dave. Okay, Dave got 3 tokens unlocked. Let's send the other vested transfer to Dave corresponding to the promotion. Also 100 tokens. 1 token will be unlocked per block. And we will start with 80 block. Okay, event about the transfer, 100 tokens, and event about creation of another vesting schedule and updating. So in that event, we can see that there are 191 unvested tokens, but with the previous unlock, there were 97 tokens. So basically, each call of vest transfer unlocks also vested and locked tokens to that account. So in that period, 6 blocks were minted. So that's why the difference is 6 in tokens. Let's check. And also, this event provides the sum of unvested tokens. Let's check how it looks in our chain state. So for Dave, we have two vesting schedules. The one that started in 70 block and the one that started at 80 block. Both 100 tokens locked and 1 tokens unlocked per block. Now, I will show how Dave can merge these two schedules into single one and what will change. So, the action needs to be done by Dave with extrinsic merge schedules. We need to specify indexes from our chain state, 0 and 1. And I am admitting transaction as Dave. Let's check event at first. So, in that event, we also can see that our vesting has been updated for Dave, and now we have 154 unvested tokens. So basically, you need to remember that also merging schedule actions also unlocks vested tokens for that account. Let's check how it looks in chain state. Of course, for Dave. Okay, for now, we have one schedule. Total sum of locked tokens is correct, but here are strange values, weird values. So this is the high time just to describe how merging process works. So we have two vesting schedules. Each one has starting block and ending block, okay? And merging schedule algorithm takes the highest block of starting blocks or current block if both schedules have started. In that case, it's 98, so both schedules were started at that time, takes the highest block as ends block, and now calculates the rate that is unlocked per block minted due to newly created first block, starting block, and ends block. So that's how merge function work, and that's all of my demo.
Let's continue with the code walkthrough. Let's deep dive a little bit. Let's check what's under the hood of all that Justin and Daniel have told us. So what we are looking at here is the config trade for the pallet. I think this was, I thought this was like a nice point of start, right? So let's have a look at the types that we define that we will require to be configured at the runtime level, and then let's jump into the different functions of the different implementations that we have here, right? We are basically like depositing events, like throwing events. So runtime event there with the frame system config. This is like very like expected or usual when dealing with runtime pallets. Then here we are expecting like some implementation of the currency trade, like through lockable currency in this case. Block number to balance. This is an interesting one. There is a lot of parts of in this palette where we are expecting or we are asking for a block number as a parameter, as a value, and then like we change that into balance type, right? And we need something that can do this conversion. That is specified on runtime level. Minimum vested transfer. This is like the minimum amount that we have to transfer, like to call vested transfer. We can see it's annotated as a constant, so this value goes as well figured as part of the constant metadata. And here the last two weight information for this palette. And max vesting schedules. This is a value just to have some bound, some limit on the amount of schedules per account, right? That we will manage here. We can see right underneath the config trait, like we are like wrapping this value, max vesting value, under a function called max vesting schedules. That we're including into the constant metadata with this annotation, like extra constants too. So these two will end up on the same part of the metadata. Why not annotating this constant here? I'm not sure. I feel that it has to do with the detail that all of these are types and this is a constant. I haven't had like really a lot of time to dive into that, even though like I'm very interested in discovering why. But we got it like through this little implementation here, right? Okay. Let me just open the Polkadot runtime super quick here, and let's see how is this like implemented for Polkadot, right? Runtime event is runtime event. Currency. Remember that we are expecting some lockable currency implementation. In our case, Pallet Balances is taking care of providing this implementation, providing all the functions, and all the details about how is this going to be managed. And like double clicking on Bruno's question from before, if we throw here a pallet that it's like multi-currency or multi-assets or something like that, that can manage like different assets, and that is like implementing lockable currency, then we can work with this. I will assume that should work. Basically, here's the point, like where we have room to play with it, right? Block numbers to balance. This little trait here, convert into, is providing us the functionality to convert a number that is block number into a number that is a balance. More or less, that is a very bad definition of the details of the implementation of this trait, but it's doing basically that. The mean vested transfer, defined here as $1 in this case, 1 unit, 1 dot. The weight info, we're taking it from the weight info generated from the benchmarks. And the max vesting schedules is 28. It's set to 28, so 28 CAD schedules per account, right? Let's jump back. And before going any further, I want to show like this struct here is part of the same palette, though it's another file. Vesting info is basically the schedule. For example, this like reflects perfectly all the information that we were like seeing during the demo. We have like a logged balance, right? We have like the per block, that is like the amount of balance that is going to be unlocked every block, and the starting block. That it's the representation of an schedule that we are going to work with during the whole palette. And then like following to this struct, we have its implementation with like different functions, but I think it's not necessary to go through them for this presentation. Okay, next thing I want to check out starts items vesting. This is basically a map that it's storing like all the schedules per account. So the account ID is our key, and then like we have this vector that obviously is bounded to max vesting schedules. We are basically bounding it to the limit that we have set at runtime, right? And then like we have all the vesting information, all the schedules for this account up to 28. Nice. Next one, storage version. this like refers to this palette, and it will be used basically on migrations, just to have like some control and don't break, don't leave any storage on. How is it called? Well, in a bad state. And that's more or less it. Like as you can see, like there's not a lot of information being stored on chain for this palette. Like 2 things, basically related to besting and the shadows, just this one here. So next thing that we find is the Genesis config, Genesis build. As Daniel has shown us how to configure like some besting on Genesis. Like let's have a look. Basically, what we are expecting on this Genesis config is a shadow, a besting info struct that we have saw before, right? And it's formed by an account ID, this block number, another block number that is like a starting point, and the number of units that will be unlocked per block, and the balance of that. This is like the liquid, the free balance that will be like remaining there. Let's have a deeper look into this. Check the Genesis build. This is Genesis build. If you're not very familiar with it, like basically it's like, okay, like you have provided me like this information here at Genesis. What do I do with that? This is the file here. This palette like takes that struct, that piece of information, and mutate some storage or like whatever it says here, right? As you can see, well, we are setting the storage version, as I said before, to releases v1. So further migrations, whenever like we need to set a new storage version for this palette, we have to take everything that is on v1 and translate it to v2, whatever that v2 might be, right? As I said before, like the information that we provide at Genesis, we have an account. This is like who, this is the account ID that will be affected by this shadow. The block, the begin block, starting block for the vesting. The length, that's number of blocks that this schedule is going to last. This will translate into number of tokens that will unlock per block. And the liquid, that this is the number of units that we want this account to have as free balance, basically. So let's go here and like per every vesting schedule that we provide on the Genesis config, we will do the following, right? We will take the balance of this account. Then we have set that Genesis balance for this account. We have like, I don't know, we have set an amount for it. We check this, we make sure that it's not 0. If it's 0, then it makes no sense that we are doing anything here, because we cannot lock an amount of this account's balance because it's 0. So here, with the liquid part that we have defined, we calculate the remaining, what is locked. We do the subtraction of the liquid part minus the total, and the remaining is the part that is locked. Then here we can see the first time we use like this block number to balance into this palette. That basically we take length, like the duration of the schedule, and we transform that number into a balance. If it said 15, we have 15, but now it's a balance. Before it was a block number. And then we calculate like how many units are going to be unlocked per block. This is very cool or interesting, right? This is just this division, like the locked divided by the length, but we have here this max. That what this max is doing basically is avoiding the situation where length as balance is 0. Max compares this value here with, in this case, 1, and basically like transforms this side of the division into like the biggest of both numbers that we're comparing. So in this case, like if you are under 1, you are 0, like if one schedule is configured to unlock 0 units per block, basically it's never going to end. So doesn't make any sense. We avoid that, and we avoid also like dividing by 0. So really nice, really cool. We have all the information needed now to create like one vesting info, one schedule. So we just like call it for a new one, and then check like if we have created like a valid schedule. Just a double check should be okay, but just a double check. This is valid comes from the implementation of the vesting info struct. We are checking that the locked amount is different than 0. The per block amount that is going to be free is also different than 0. So basically, that it makes sense. Once we have like our vesting info, we like append it to vesting. That this is like the vector, the list of all the schedules that apply to this account here. And then like we are applying a lock that this is something that relates to balances palette that it has already been covered on these sessions, but like just like a reference, you set a lock to some tokens. Those tokens are not considered free because they are under a lock, so you can transfer them. You though can still like use them for staking or voting, governance, and that stuff, right? One funny thing I found like super interesting when reviewing this palette, we have the reasons here for a lock. When we apply a lock, we have to give like some reason, like why are we locking like some balance of this account, right? And in this case, we can see that we have like transfer and reserve as reasons, and then we have like this operator here that is something similar to a OR, but usually like when you see an OR operation is 2 of these, but here we only have 1. This is like, if I'm not wrong, a bit or something like that. It's called. I might be like using the wrong name. But let me like jump into GitHub and show you like why this is like that. We have like some primitive, some like reasons defined here in this trade, right? And these are defined as bit flags. So if we are working with bit flags, we have to set our minds on something like sets. Like we are building like a set of different elements that are part of this, wider definition here. So we can our definition can have like 1, 2, 3, whatever until the maximum, right? Like for example, here reasons have transfer and reserve. So our reasons are these 2. This basically when we are working with these bit flags, this operator means union. So we are creating like this union of these 2 reasons. I thought it was cool. It was interesting. If some of you go then later on and check on Polkadot your vesting information for your account or other accounts or whatever, most likely is that you are not going to see any of this as a reason. I did with my account, and I said like, okay, like why is the reason showing for my account not in this list? This is the reason for it. There is like a little wrapper, a little simplified version of the reasons here that reduced the whole options to 3 of them. And then like basically you have all if you have payment on something else, or you have fee if you have payment. And if that's not the case, like then you just go like MISC and that's it. And most likely this is what you will find as a reason for your vesting lock on your schedule. Well, going back to the topic of this presentation, we set the lock right for this schedule, and that's it. And we have finished. We are done with the Genesis testing. If we continue reading the palette, then we have like some definition of events. We have seen like this in action during the demo, and then we have like some errors that will like help us to understand what is happening if we are trying to sign some extrinsic that have some information that is not correct. And then we have the definition of the extrinsics. The first one being best. We have already seen what happens when we call best, like we vest some funds from the total schedule, from the total invested amount that was like configured for us, and we get like some free balance that was locked previously, right? Here, like on the extrinsic, we're just checking that the person that is emitting, like submitting this extrinsic, has signed it. We're checking if it's signed. If it's signed, then we continue and we like execute the best. We can have a peek later on this if you want. Next one in line, best other. This is the extrinsic that Daniel was sending from Bob to David in order to unlock to best some funds for David. Basically, with this extrinsic, you can like best some tokens for another account, right? And obviously, as it is the target of this action is another account, then you have another parameter here that is another something is the target, right? Cool thing is defined as an account ID lookup, is not defined as an account ID, because this palette like defines uses lookups and defines like account ID lookup of and implementation of static lookup. And what we are doing inside here is like, okay, like the person submitting this extrinsic has signed it. In case it has, then we look up for the target. Basically, we are retrieving the account ID of whatever is in here, and then we do best for this target account that we have like lookup. Lookups are very cool, they're very interesting. I really recommend you to have a peek on them if you're interested. Sadly, like you will have to enter into a source code to see like how they work and that. If you're very technical, that might be a bit rough, but they enable like very cool things like defining. They give you like more room, to do things like, okay, like maybe this target here doesn't have to be an account ID, doesn't have to be a Substrate account. That can be an Ethereum account, maybe a name. Through the implementation of this function, taking care of translating that into an account ID that is that Substrate can understand. Or maybe this can be Alejandro ... and I translate it here to a Substrate account. So very cool thing, account lookups. Next extrinsic, vested transfer. We can send some funds, some amount of tokens to another account with a schedule on top of it, and those tokens will be unlocking over time. For example, here, have a look at this. Obviously, like we have an origin and we have a target account, and then we have the schedule, right? What we're doing here is like saying, okay, like we need to check if this extrinsic is signed or not, like as usual. We do like that by insert sign. This is giving us back an account ID. And now we're doing an unlookup. That this is funny because it's like, okay, we already have an account ID. Why are we going back to this type here, account ID lookup of? But like if we check the best transfer, we are sending transactor. That is this like account ID lookup of. We are sending the target. This again account lookup of, and then the schedule. Basically, do best transfer is like looking up for those here. So if we send an account ID, then it will be a little less inconsistent. That way, like, just makes more sense. And like this is the very last extrinsic that we can call here, and it's merge schedules. Definitely like the more interesting one in terms of like how it's implemented. And like here on the comments, if I remember correctly, I do. And there's like these little notes here that I can explain really well how like these two schedules are going to be merged. Daniel or Bale explained it perfectly. Both of them will like merge into a new one. One new one will be created out of the information of these two. The starting block will be like even either of like the bigger starting block of the two schedules or the current one if they have already like started. Then the ending block, again, the biggest of the two schedules that we want to merge, and the locked amount is the addition of both. Right? How am I doing on time? 10 minutes, something like that. Let's try to do it in 5 and save like 7 times for some questions. So yeah, let's go through this. Obviously check if extrinsic is signed. If not, like we stop here. Next thing, if we are trying to merge like the same schedule 2 times, we don't do any operations. We just like say, okay, like, that's fine. The new schedule is going to be like the same one as the old one. There is no operations to do here. So that is there too. We take the indices of both of the schedules, and then like we retrieve all the schedules for the account, if any. If not, like we return an error. And then like we define like this merge action. Merge best in actions is a little struct defined here on top of the palette. Like this can be like passive, remove, or merge. Right? We are right now like taking care of merge. So merge is the action that we want, and inside we define like the 2 indices for the 2 schedules that should be merged. Now we have the action that we want to make. We have the information. We call execute action, exec actions, with the list of schedules that we have retrieved from here, and the action that the action like has the information for the 2 schedules that we want to merge. Let's check this one. Execute action, exec actions. So this action, in case it is a merge, we execute the following logic. Get the IDs of the 2 indices. Get the schedules based on the indices that we are sharing from the whole list of schedules that apply to the account that we are taking care of. Then report schedules updates. Here, let's have a peek to this one. All right, here what we are doing is filtering from the list of the whole of all the schedules that are effective applied to the account. We are filtering like the 2 that we want to merge. So if we have a list of 5 and we want to merge 2, then we take those out. The list reduces to 3 in length, and that helps for the following calculations. Okay. Then, well, this action like also like counts the locked amount, total locked amount in between like all the schedules, but the 2 that we want to merge. So the 2 that we want to merge are not taken into account into this whole like computation for the total amount of locked funds for this account, right? And then we continue. We check like in which block are we now, and we go like best in info. Best in info here is the point that where we like create this new schedule, this new like best in info out of the information of this other 2. The new schedule is created. This is the return here. And with this information, then we just like take the new schedule, we push it into the list from which we previously like take out like the two schedules in the action before. And then like we calculate like the new locked amount, and we like for these two, and we like make addition to the previous one, so we can return the whole new list and the total locked amount like over, and then we just like return it. All right, like this will execute if we are not doing like a merge action. And I will stop here. There is nothing else. Then maybe we can wrap it up here. See you around. Thank you for coming. I hope this was useful.